Hey guys, in this video I'm going to show you how to draw the Lewis dot structure for C5H12, which is pentane. So here we go. C5H12, which is a chemical formula for pentane. That's going to give us 5 carbons with 4 valence electrons for each carbon, plus 12 hydrogens times 1 valence electron per hydrogen. So that's going to give us a total of 32 valence electrons. Okay. And if you see any of my other videos for the alkane compounds, essentially the structure I show you is just a straight chain of carbons, and each one, as you increase with one more carbon, you just add on to the chain. So that's what I'll show you here. We have, so it's 5 carbons, and since hydrogens can't be central atoms, all the carbons have to be the central atom. So go ahead and start drawing our carbon chain. 5 carbons, and we have 12 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we can go ahead and attach them all with single bonds, because hydrogens can only have single bonds. And now, if you notice, every carbon has 4 bonds, which gives it its full 8 octet electrons, and each hydrogen has a single bond, which has 2 electrons, which is all the electrons that a hydrogen atom can hold. So we can go ahead and count them up, see if we have 32. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 bonds. 16 bonds times 2 gives you the 32 electrons that we have from valence. So that's exactly what we're looking for. Alright, so let's go ahead and check the formal charges now. So the formal charges for the carbon, because if you notice, every carbon has the same setup, same number of bonds, so the formal charges should all be equal. So formal charge is the number of valence brought in, which is 4, minus number of bonds, 4, 1, 2, 3, 4, minus number of non-bonding electrons, and there's none of those, so the formal charge is 0. Okay, now the formal charge on the hydrogens is number of valence brought in, 1, minus number of bonds, 1, minus number of non-bonding electrons, 0, which is also 0. So that these are going to sum up to be an overall formal charge of 0, which is exactly what you're looking for in a non-charged compound, like this one. Okay? Now, each carbon in here, it has 4 bonding sites, which means that for each carbon, they're going to be sp3 hybridized, because there's 1, 2, 3, 4 bonding sites, sp-pp, sp3. So that's going to be sp3 hybrid for each carbon in the center of the chain. Okay? And because each carbon is sp3 hybridized, that means that each carbon, like this whole shape, is going to be composed of multiple tetrahedral shapes, because each carbon, this group here is tetrahedral, this group here is tetrahedral, so they kind of build off each other in a unique fashion. Okay, and because all the hydrogens will cancel each other out in terms of net dipole moment, this is going to be a non-polar compound, which is the case for most organic compounds such as C5H12 and most of the other alkanes in organic compounds. So that's pretty much it. If you have any questions, leave them in the comments. Any special requests, send me a message. I'll try to put it in the video for you. And thanks for watching.